Hello everyone. Today we'll look at assembly of the most of the technologies that we have practiced in this semester. So let's put them all together in the developments. All right. So data sources that we are using for this the illustration is from cloud database, Raspberry Pi. We have the text files from Raspberry Pi and local databases. On your the project, you may include more. You may include maybe 2 Raspberry Pis or 2 local databases or 2 cloud databases, things like that. Okay, and the format of data that we can finally receive hopefully JSON, but today's the implementation, we don't do much about that, partly because I want to make this more general purpose. But when you do your the project, then you can define it more specifically. Then you can convert the data into a specific JSON, because the JSON files is nothing but the key and value pairs, right? Key, therefore, in your specific applications is preset. It is defined already, right? But in general purpose, it is not. And also, the goal of our the data, the aggregation is not really specific. It's not really defined, right? So you can, on your application, you need to do the real the aggregations. So the one that I implemented a little bit, the prototypes, we have a cloud from Google, cloud server, and Raspberry Pi. That should be up and running. Remember that in the last session, then in the Raspberry Pi, you have to do something, right? You can some specific data can be returned, but in my demo, I included that in today's assembly. Simply the Linux command that I ask to the Raspberry Pi, then the Raspberry Pi execute that, and the result is returned to our laptop. Laptop, of course, we have MySQL is running. So the idea here is this is a graphical user interface, and this is the opposite. This is a local database here and cloud in the other side, and in the middle there is Raspberry Pi. Okay, so I would say it could be this come here, that goes, oops, that goes over there, should be here. So in our database, we have direct access from my Python code, and then Raspberry Pi. And also we practiced a lot communicating with the cloud server. This is this may be the last homework assignments before you do your the project, but I'm going to show to you if we can expand that a little further. Then another the frame on the bottom, we can get the data from there and execute something, so additional things can be done here, right? This the pink frame you don't need to do, but in my demo I can share some of the preliminary work with you. All right, I think this. Okay, so I'm going to give you a demo about this little more advanced the prototypes that I implemented, and then I will ask you to do this. This is all your version. This is my current still primitive work. I'll give you a demo for that. So this is the program. Remember that this frame in the middle of top level, those are the this is a text box, so-called entry and button. These two items for the local database, and then Raspberry Pi IP address, port number, and the button. Those three can work for the middle here. That is for the mobile Raspberry Pi communication. And then the last one here to communicate to the Google Cloud server that we the setup and configured the weeks ago. So collectively, we can get some data from each, and my demo, there's no common goal to collect data, but in your application, you don't have to follow this, but if you want, you can do collect for the same the application domain. So the data that you can get from your local laptop, data that can carry over to mobile Raspberry Pi, for example, delivery system, then delivery trucks, maybe here in mobile Raspberry Pi, and this is your maybe distribution center. This is maybe the headquarters where there is a controlling all the process cloud server. And then the bottom here, maybe you as a customer, or maybe customer service center trying to figure out what's going on. Some of the order, there may be some issue, then we can communicate with the truck driver. We can communicate with some of the items availability and also some of the global monitoring and controlling systems, that type of things. It's a little bit wider. So for simulation, as we open this, it accesses already types of CyberDB database, then class, enroll, and students. So for this local database, we can issue SQL students by clicking this. Then the result of student table can be displayed here. That is that. For this Raspberry Pi, we need to make sure that Raspberry Pi is running. So VNC, and I want to see this is the one. I want to access. What happens? Okay, so minimize this a little, not minimize, smaller size. Don't forget that here, all the server needs to be up and running before you use this, of course, right? Local, my database is running. Therefore, I can, by clicking this, the Python module to connect the database and get the result from there. And same thing here. Remember that we discussed the last sessions, right? That Python module should sit behind of this button. Meanwhile, at this Raspberry Pi, server needs to be up and running, right? So here, project 24, and then that server system needs to be run and ready to listen any request from the client, which is here, right? So, and also we need to make sure the URL, I mean the IP address, 192.168.140. So I am going to use that. So 192.168.140, and the port number is 2545, and I want to fetch the mobile Raspberry Pi. I remember that as a sample testing, I can send one of the Linux command. I want to see the list of the content in the top level etc. And when I hit the button send, that came up here, right? That is from that the server. That appears here also as I typed, requested. And here on our the Google Cloud server, remember the customer, the order, customer orders may be fetched by customer name. So if I put John and fetch for the orders, any items orders by John, I click this and it goes to the Google Cloud server. So that I have here all of these John's order, right? You could do like this. What I want to do here, for example, I want to get, you can do for your own application goal, but when I click this, share JSON data, then this one, the one that I showed here, because I made that, this one can come up here. And then if I say, what should I execute here? Some of the Python code may be able to execute it here. So what I want to do, the Pythons, so let's say what am I doing? Anything that you may be able to do. For example, I want to, let's say this is a result. Result equals, and this is something that I can show as a, from here there, that is one item in the list. and then I could have another, oops, from here there is another item to the end for simplicity. So I have here item in quote, comma, and another item in quote. Outside that is a list, and this is the variable for list, right? So if I want to do, for example, print result, and then if I say print my result, I want to print this. So if I highlight this and execute that, there is an execute error. Let's see. There is also error. If I put print let's see if this can be executed. It's not really an issue here. So execution for that. This execution is not really work, but anyway, this may be working. Let's do something else. When I do this, okay. What should I say? PWD, print working directory, and this is hung. But anyway, something like this, okay? Let me close this. I'm not sure this can be. I'll stop. I'll interrupt the code. Okay, so that is interrupted. And the simple code that I can show to you is this. Okay, this is something that I already showed it to you, right? So select star from class, then we can see the list of the class. And similarly here, 192.168.68.140, and port number is 20545, and fetch. Then we can get, for example, PWD, what is my working directory? It doesn't. Oh, server is down. So server should be running up. So we can fetch, and here PWD, then it should give to me. This is my working directory, right? and this is the same as before, right? If we put here John, then we can see the list of John's order. This much I ask you to do for your practice, but you can extend from this and more. The code, if I show it to you, you can import TK frame, label, entry, button, string variable, int variable, and text and insert. This is for the database access. This is for communicate with the Google the cloud middleware, and this is something that I deal with the JSON, dealing with the data date format. Therefore, somebody, if you want to change it to date format to JSON, then you may want to need this. But actually, in my application, I didn't convert that to JSON except this. Okay, this is a JSON. This guy, this is the date format, but it can. I believe this is a not really date form. I'm not sure, but here, your local data, if there is a date, then it should be properly handled. Therefore, I have this. This catalog, initially I want to show the tables. Therefore, I use this. And for this local left side, then to access the local MySQL, then you need to connect that and use the database. And then you need to fetch, execute the SQL. Remember that from the GUI, if you want, you received the parameter, SQL parameter, that was set before it was sent to you. When you received this, then you need to get, you need to open that parameter to get the value only. In that case, you need to have a sq.get. This is only the case when you have graphical user interface. This is a local SQL. This has been called from your here. Remember that here button. That is the button here, local MySQL. So this is name of that button. And when this button is clicked, then function is to be activated. The function is MySQL. This MySQL function has an argument D. If you want to send the arguments, then you need to, if you don't need to send any argument, then you don't need to hear lambda and all of this. You simply say command equals function, open and close parentheses. But if you send the argument here, then you need to use lambda function, and then this variable is to be defined. So D is nothing but user SQL. User SQL is here in this entry. This guy says enter your, right, this is entry. Entry is nothing but this. This is entry. This is text field. So the width 10, that text field needs to be taken out. That user SQL is passed to the function. When that function comes, then the SQL itself needs to be taken out and executed and fetch, and then we can we displayed the list of no, we displayed the database only, the table in that. It's not really. Oh, we didn't do anything, and it insert only when we have here all this insert. Here, I changed it to the JSON format, but it didn't display it here. But I could JSON itself, right? But I didn't do that. If you want, we could do that here. For example, I want to comment this, then I can do only this, and here insert, and I do not need to do this. Instead of this, local data. So as an example, if I execute this, and when I do select star from students, then you may be able to see here the result of this SQL in JSON formats. This is JSON formats, right? CWID 1234, name, and so on and so forth. Previously, I showed that in a little bit like database tables. That's what I did here, and also to communicate with this Raspberry Pi, create TCP clients. I believe this is the same as the other one that we looked at previous, and to talk to cloud, same thing that we did this, right? And the rest of this is the graphical user interface. So I made the TK object first, and then title is distributed data services. That's what we have here, and then frame, light blue, light gray, and light green. This is in column 0, row 1, column 0. No. No, yeah. Upper frame and low frame, and then on the top, this upper frame, lower frame, lower left to lower. This is something upper frame. Upper frame is this upper frame, lower left to lower middle, and lower right. So lower frame, that is upper frame, that is a row number 0, column 0. Row number 1, column 0. Upper here, that is row 1. The bottom, all of this is row. This is row 0. This is row equal 1. Within this frame, I have here lower left, lower center, lower right frames, which is within this row 1, column 0, column 1, column 2. This is column 0, and next one is column 1, 2. So left one is light green, the middle one is pink, and the right one is yellow. So right one is yellow, this is pink, this is green, right? So we define that, and we put the labels. So here, enter SQL, this is a top level. Enter SQL RPI, IP, port number, customer, and then here local MySQL, which is the button. So I have a button and electronic fetching, a cloud server, and another one here fetching the mobile Raspberry Pis. So all of this, something about the here top level frame, and in the middle level frames, the low level frames like this, no, somewhere here. And then when you enter, when you insert the data into the frame, then we use like here the insert, user insert, and then data. Same thing here, display and insert into. Similarly here, that I just showed it to you. So each of this has a display. So we declare the displays. Here, the text, this frame contains text objects. So this text contained in the lower left frame. So frame contains text where you can write something, not directly into frame, but frame contains text, and the text object can display something, so that you made that the text, and then you call it the different name to the left side, middle, and right side. So left side, all this display, and in the grid format, that is a row 0 and column 0. Sticky northwest, north, southeast, west. That means you want to put that on the center. And pad X, pad Y means you want to make a pad along X-axis and along Y-axis. That much you need to have some of the paddings. Okay, I believe that is something that I can point out to you. All right. Okay, this is a way of aggregating data from various different sources. In this demo, I showed you 3 different data sources. You could do more and better. Okay, thank you.